Alright, welcome back to this next video where we are going to be talking about the test for an AP. Now, in the previous two videos, I actually went through the idea of what's the general term of an AP as well as the sum of an AP, right? So those are the very two crucial formulas that you need to know by now. So make sure to watch the previous videos if you have not fully grasped the idea of what an AP is yet, right? But in this video, we're going to be going through the third most important formula or the most important workflow that you need to know when it comes to an AP, and that's testing for an AP. So the idea behind this concept is very simple. Given a sequence, right, how do we know whether it's an AP or not? So there's a lot of ways to show something's an AP, but I'm just going to use an example to show you, right? Let's say given this sequence over here, for example 2, okay, I don't use 2, use another one. Let's say here is 4, 7, 10, 13, 16, 19, right? We know that the common difference is 3, right? Plus 3, plus 3, plus 3, plus 3, plus 3. One look, we know that this is an AP, right? We know that this is an AP because there is a constant difference between each term of plus 3. So this is a very simple way of looking at it, right? But what happens when, let's say, the question gives us, it does not give us a sequence, right? Because why would they give us a sequence and ask us to derive whether it's an AP or not when, you know, it's so obvious that it's an AP, right? So typically in most questions, right, they won't give you the sequence itself. They'll give you the general formula. So usually questions will give the general term instead. Okay, so let me just give you an example over here. So let's just say, for instance, given a general formula of Tn, right? Tn equals to, let's say, 5n plus 3 over here. How do we tell that this is an AP? The answer to this is very, very simple, right? Imagine this, right? Tn of a sequence. It means that in a sequence like that, let's say I have a term over here, I have a term over here, I have a term over here. This is Tn minus 1, this is Tn, right? And then this is the term. So this Tn over here would be 5n plus 3. Now, it doesn't matter what the value of n is because this is a very generalized case. But we know that the characteristic of an AP is that the difference between two terms have a constant difference of d, right? Which means that when I take, or should I take Tn minus Tn minus 1, right? If I take these two minus away each other, I should be getting a constant, right? A number. So we'll call this a constant that's independent of n. Now, independent of n is just a very fanciful word of saying that it does not contain a variable, right? Which is n. But it's true, right? Because if this general term was truly a general term of an AP, right? And if we take Tn minus Tn minus 1, which is essentially the term before the Tn term, the difference between these two terms should be a constant because this is an AP. And since it's a constant, it should be a number that does not contain n. Because if it contains n, then it's no longer a constant already, right? It's a variable. So how do we actually show it in this case? Very simple. We first find out what's our Tn minus 1 term, right? So Tn minus 1 would just be 5 times n minus 1 plus 3, right? Because the only difference is that now, instead of having n over here and n over here, I have n minus 1, which essentially is n minus 1. So all I need to do is to replace n with n minus 1 to get the n minus 1 term, right? Because over there, that's the variable. And over here, I will get 5n minus 5 plus 3, which is 5n minus 2. So putting these two together, I have Tn minus, or rather, minus Tn plus 1 or minus 1. This will give me 5n plus 3, which is Tn. Then I minus away 5n minus 2, which is essentially just 5n plus 3 minus 5n plus 2, which essentially is just 5, right? So you can see that the two 5n's will cancel each other out, and therefore I only end up with something that is just a constant that does not have n. Does not have n, right? So this is a very, very classic way, and in fact, this is the method to actually prove that something is an AP. Right, given the general term of a sequence, we do not know for sure whether it's an AP. But in order to show that it's an AP, the way that we do it is that we take Tn minus 1 to show that the result is a constant independent of n. So I'm just going to write down the explanation here. So since Tn minus 1 is a constant independent of n, comma, right? This is an AP. Proven. Okay? But before we actually proceed, I want to also give you a very classic case questions whereby you will actually see being applied the first example question over here already. Right, so usually questions that test this concept here, right? Sometimes they won't give you the Tn straight away, right? So there is also a case whereby you have to figure what's the Tn as well before you actually can jump to this step, right? The general term. So I'm just going to be introducing another concept over here in the top left-hand corner here, right? So I'm just going to summarize the workflow first. So the typical workflow is that we have Tn, right? We have, or rather I write here, we have Tn. Then from here we find Tn minus 1, right? Then we take Tn minus 1 equals to constant that's independent of n. Then from here, then we conclude, right? Therefore, we conclude that whatever, right? But sometimes the question, before that, they want you to derive the Tn. And what would they give you? They will give you sometimes, okay, I'm just going to write here, sometimes the question will give Sn. And therefore, you have to derive Tn yourself first, which is, that's how you get to this step over here. So given S, how do you find Tn? That's the question that we are going to address now. So Sn is basically just S1, or rather is basically just T1 plus T2 all the way until Tn, right? Because Sn is basically the sum of the first n terms. So if you want just Tn alone, naturally you will need to get rid of every single one of these until the Tn term is left, right? So how do you get rid of all of that? So I'm just going to write it here. In order to get just Tn, you need to take Sn, which is the sum of all of the first n terms up until the n term. You need to minus away the n minus 1, sum of the first n minus 1 terms. Why do I say that? It's because Sn essentially is T1, T2, all the way until Tn. But Sn minus 1 is T1 plus T2 all the way until Tn minus 1. So when we subtract away these two from each other, you realize that this whole thing here will strike out this whole thing up until here. And that leaves you with only Tn. So sometimes the question will give you Sn, and then you have to use this formula over here to derive what's Tn. And once you derive what's Tn already, then you repeat the same workflow that we discussed earlier to conclude that something is an AP or not. Okay, but not to worry, because if this seems a little bit too abstract right now, you just need to understand this concept for now, right? Because right now, we are going to be tackling this question over here that actually allows us to practice whatever we adjusted. So pause this video right now to actually go and try this out for yourself. And once you're done trying this out for yourself, come back to this video and we'll actually go through this video answers to this question over here. Okay, so let's just jump right into this. So we are given Sn and we are asked to find what's the n term of this sequence, right? And thereafter show that this is part of an AP. So actually the good thing about this question is that it's exactly what I mentioned earlier, right? It's just that they are kind enough to guide us, right? Like first we need to find the n term and then from there prove that it's an AP. So we'll actually do this together. So once again, the formula starts off as Sn equals to n times n plus 2, right? And we know that Sn essentially is T1 plus T2 plus ... plus Tn minus 1 plus Tn, right? It's the sum of the first n terms. So in order for us to derive what is the Tn term, we need to take Sn minus 1, because this is essentially is just T1 plus T2 plus ... plus Tn minus 1 plus Tn, right? And then we are minusing away T1 plus T2 plus all the way until Tn minus 1. Right, so we are actually subtracting away this portion away from this portion up until here. So what's left is just Tn here, right? So that's the idea behind it. So we know that our Sn essentially is n times n plus 2. And then how about our Sn minus 1? So to get Sn minus 1, we just need to replace the n over here with n minus 1. So this would be n minus 1 times n minus 1 plus 2. So in the end, we get n squared plus 2n minus n minus 1 times n plus 1, right? So this one we'll get n squared plus 2n minus your a squared minus b squared, right? Because it's a minus b, a plus b. So a squared minus b squared, which is n squared plus 2n minus n squared plus 1, which is actually just 2n plus 1, right? So this is our Tn, which is 2n plus 1, because the n squared will cancel each other. So from here, we know that Tn is 2n plus 1. So how do we show that terms are in an AP? So to recall, right, how do we know it's an AP? Is when the consecutive terms have a constant difference. So for this to be an AP, we know that Tn minus Tn minus 1 has to be a constant, right? Because the difference between two consecutive terms must be a constant difference. So from here, we know that Tn minus 1 would therefore be 2 times n minus 1 plus 1, right? Which is just 2n minus 2 plus 1, which is 2n minus 1. So combining these two, when I take Tn minus 1, I end up with 2n plus 1 minus away my 2n minus 1, which eventually gives me 2n plus 1 minus 2n plus 1. And then you realize that these two strikes each other out, and eventually you get 2 over here. So we will conclude and say that since Tn minus 1 is a constant independent of n, right, which is essentially just 2, this sequence is an AP. So yep, that's how we prove that this sequence over here is an AP, and it's basically whatever we just went through in the previous video, but we just really apply whatever we learned in this question over here. So let me know if you got any other questions in the comments below. If not, that pretty much wraps up AP for us, because in the next video onwards, we'll be actually going through GP, which is another type of sequence. Okay, so just to recap, right? Everything we have been learning so far is all sequences. It's just that an AP is a very specific type of sequence, right? And in the next video onwards, we will be going into another specific type of sequence, which is called GP, whereby the difference between each term is a constant multiple. Okay, if not, no more questions. I'll see you in the next video. I'll see you there.